let's do it in Oregon. And he opened the factory in Portland. Here he is.
Hello, everybody. Thanks for the intro, Greg. It wasn't quite like that, but similar. So there was a $5 million problem in between. So, unfortunately, those setups are really expensive. And, at the time, I was just kind of more dreaming about it than actually really doing it. And we're really lucky. Greg is really, from anybody, is probably the one person that believed the most in me as as an expert or whatever, but also in the whole system and doing more technology in building, not just wood framing, but in general, just how can we integrate technology. So I just came back from Australia about, 3 weeks ago. I gave that talk there, and we've been so busy, or I was too lazy, or take it whichever way you want. So I'm gonna show you the same presentation, but I think it will apply here just as much as it did in Australia. Australia is a very different market. CLT and mass timbers is really booming, despite the fact that they don't have wood like we have. That's why I say it's like we're really blessed in a way that the material we have. But it's just the demand. It's so booming, and a lot of people want a better product. Like like some people want organic tomatoes, and other people want buildings that are sustainable, and they're willing to pay good money for that. So I'm going to go through that a little bit, and the people that know me, they've probably already seen some of the slides and kind of understand some of it. I'm, like I say, half of me is a craftsman. I was just actually coming from the shop, like doing things, and the other half is kind of a technology, part dreamer, part, hoping for the future, and I get really excited about all those machines and whatnot. And so I came from the craftsmanship, like my dad did everything by hand, so it's like more handwork to then going to the software industry. Now I'm back in the shop, but now we're doing both. We're doing software and craftsmanship. So we still have a chainsaw with no Bluetooth interface, but we also have saws that are very well connected. So let's see if I can kind of slide through that. So this is really what Cut My Timber is all about. Like I say, the main problem at the time was we didn't have several millions laying around, and I didn't really want to take any money from investors that tell me how to do things, although they've never done it, or they didn't really, it's like I've seen that many times. Like you go to a machine company, it's like, oh, how many walls can we produce with this thing in a day? And they say, well, you produce like 500 walls. And so it's like, oh, great, so we're going to get 10 of those machines, and we're all going to get rich, and we're going to build like 10 buildings a day. And that, for some reason, never worked out, just because it's not quite as simple. So my idea was with Cut My Timber is kind of like I knew all those people that had machines, and I kind of thought I had a good process, and I kind of knew how to do that. So I figured, well, we don't really need a factory. We're just going to do like a virtual factory, similar to what you would do with your photos, like not everybody has like a $10,000 photo printer at home, so you just send a digital file and they do prints that some people want the prints. So I want to do the same thing with timber and steel components. It's like we can work everything out, detail it, make it work, do the logistics and everything, and then we just send a machine file to machine. So I started with that, and then part of me was the desire that I wanted the shop, and then the other part was just the need. Is like it's hard to do everything electronically. There's just, like Thomas said, it's not real until it's real, and you run simulations and everything works great, and then you run the real piece, and just the one you're running just happens to have a little crown or a little bend or something. So that's always something that was an issue. People kind of like, how accurate are those machines? It's like, well, they're really accurate. How accurate is your wood? And the answer is it's often not very accurate. So that's kind of the story of Cut My Timber. This is a thing we did in Vancouver. This is a temporary setup for the TED stage in the theater. So this is a seating structure. That's the backside. So we cut like 12,000 glue lamp components here in Portland on 2 machines, 2 shifts, and we had those all cut in 3.5 weeks. So that was kind of, and in the end, we didn't even run both machines non-stop. Like for a while, it was cool. We had them running in forklifts, driving. It was just kind of, wow, we could do all of that. But it was very well prepared, and everybody was important. So that was a cool project in many ways. We're also really involved in the whole digital fabrication network. This is more Greg's thing. I don't think I need to say all that much. This is the art museum, the new one, SF Noma in San Francisco, and it's kind of an organic way of building a facade. So Bill Chrysler and his team, they did that. Everything was molded and then basically milled into foam. And it's interesting for me. Obviously we're all kind of geeks and we like to geek out, but I meet with people cutting steel, cutting foam, cutting sculptures or 3D printing things, and there's people, they don't even know what a CLT is or a glue lamp, but it's a common language. We all have the same issues, like in the digital world, like design to basically do the fabrication. In the end, it doesn't matter what the machine or the industry is, like we still have the same hurdles to fight. So this is a really good organization, and I always kind of enjoy talking to like-minded people. What's going on in wood? So this is kind of, we just, like early this year, we got finally, after working for years with German equipment, I finally get a Swiss machine in the shop, so I'm really proud of that. And not to say it's like 10 folds better than the German one. They're both great machines, and some, they have weaknesses and strengths. But so I bought that one, and that's their latest generation. So that's kind of where it's headed now. So those machines become a lot more complex. There is more mill heads, more axes. They just installed one of those machines. That's a Cruzy MC15 that they just released about 6 months ago, just after I bought mine. So basically they installed a machine in Austria. It has like 2 5-axis saws and 4 multi-tool units like that. So they're all like basically 5-axis too, and it allows 6-sided processing. And the cool thing is like each axis is individual control and spindle drives and variable speed. And this is all geek stuff, but the reality is it's those machines came long ways in the last 10 years and mostly through software. Now we're in a way where the machine is not really the problem anymore. We have problems elsewhere. And I mean, you're still limited to whatever tooling can do, and I'm always talking about machine-friendly design, just because this is really, it's not just that we're lazy to do the rest of it by hand, but often that last 5%, that's where it gets screwed up. Either something is missing or something is overdone and whatnot. To the right, this is a timber frame. That's just to give you an idea about size, like those beams, that's an 8 by 12 post, and then those on the side, those are 6 by 10, just floor choice, again, like it used to be in a different order. It used to be, nobody's 3D modeling, nobody has good files, we have to always redo the work. Now it's different. Everybody has a 3D model, but we don't want to share it because I don't want to be on the hook if your model is bad. And so there's all of that now. It's like the legal hurdle. At what point is a 3D file or a machine file a legal document? Or often it's like, that's all great, let's do it all digital, but we still want everything paper as well. So that's something that us as an industry with designers and engineers and general contractors, we need to kind of push that harder, because that's really, there's probably as much efficiency on the front end as it is by buying robots and machines on the back end. It's really, we see that in order to cut wood for a week, we spend weeks and months like doing design work, programming, and figuring out details, and that's time well spent, but often things get done multiple times by multiple people. So this is really the, when is it legal and whatnot. This is also an issue. If you're doing conceptual design, you probably don't care much about a 16th. If I program a machine, I care very much. I mean, this is like a big deal. We need to, the programming has to be 100% accurate, because if you're already off there, the product, it just keeps adding. It's like a 16th here, a 16th there. In the end, of building like frameworks, your foot too short or too long or something. So that's something we have to kind of come up to terms, who models what and how accurate and when, and then at what point you turn it over to the next level. Appropriate skilled workers, that's another thing. I hear that a lot too. Is like, well, that guy's really good at modeling, but he doesn't know how to build, or there's builder people, they can't really open a computer or turn a computer on. So this is also an issue. If somebody's really good at the programming machines or doing CAD, they're probably going to work for Boeing or for Amazon or somebody and get paid like 5 times as what they would make in the building industry. So I think also on the education level, there's a huge opportunity that basically if we train those people now, we should train them now because we're going to need them. And then competing standards, everybody thinks their software's the best and their file's the right one, and that kind of limits basically the collaboration. What to do, how to move forward, we talk about that a lot. I think we should not. The building industry is probably from all industries the one that is the most behind when it comes to technology. So rather than trying to figure that all out, we should probably look what the car industry did, what the mechanical industry did, and so on. And we see a trend now, like for instance, like that cruising machine, they're using an ISO format, and you can install whatever CAM system you want. You don't have to buy theirs. And I see that now more machines, and that's been like that in the mechanical industry for years. So I think that's slowly coming. Data flow, I don't know, it's like, I don't want to turn that into a BIM presentation. I don't think everybody seen enough of that, but it's, that always comes up in the beginning of a process too. And for me, the answer is really collaborate together. Like with Albina, that was such a good thing. Like we were really, Thomas and his team, the structural engineer, everybody came to the shop, and you know, I already complained when I saw the first detail that it's kind of weird, and then we cut a steel plate, I think it was a 1-inch plate, and then I was just like, here's that plate, and it was like 50 pounds or something, and I didn't even have to say anything anymore. Suddenly that was so clear for everybody, and it's just like having that real experience, and that was great, and we were able, by doing that, I think to me that steel plate broke the ice, and from then on there was really a good team, and we didn't have to, this wasn't just a one-way thing. There was a phone call and a good talk, and then a solution followed by that. And I would really encourage you guys to, you know, work together and be proud together of what you do, and that's something like frameworks or a project on that scale. That's really the only way to make that happen, I think. Otherwise, it's just not going to happen. So. Data flow goals, it's kind of like how can we avoid that? Again, we like design workshops. I always invite people to come to our shop, and you know, they can see the machine, they know what the machine can do, what the constraints are. It's really helpful if everybody's local. I think that on pretty much every project, that's just, it's so much as good as those tools are, it's just so valuable if we can all sit in the same table and look at the same piece of material. Another thing that I always ask, keep the data lean. It's like that's a huge issue now too with technology. It's too easy to produce a lot of data. It's like, for a while I always thought people get paid by how many pages they print or whatever, and we have the same thing with files now. It's almost like, well, people get paid by creating more digital, you know, useless data. So you know, try to keep it lean, and then if you pass it along, try to only pass along what's relevant for the next level. Otherwise, it takes hours and hours to convert those files, and often it just doesn't really work out. Collisions and clash checks. This is more of a tool thing. That's you know, that helps too. But you know, before we cut anything in our shop, we run a clash check, and then we usually try to cut one piece and see if it fits. So we always do a real size test fit before we run 20 parts, and so that's always a good thing. Problem, like I say, file's too big. Who does what and when? So we have so many different versions, and that also has to do a little bit like who works together. You know, the teams get bigger, and it's just like synchronizing that is really difficult. And I think it's almost a point, and some companies have that, where you need a digital data manager of some sort. It's too hard just between team members. They're focused on their design or their engineering or their fabrication. Somebody needs to be on top of that and kind of, you know, manage that. Otherwise, it's difficult. I don't know who of you is using those teams, but of course every time there's a problem, some software company comes up with what they claim the golden solution. I personally, I use all of those a little bit, and I haven't found the golden solution yet. And the problem is so complex, and it's not repetitive. It's hard to find a solution. With that said, it's great to see where that's going. And if those tools would do what they promise to do, and maybe one day they will, then I think the whole data management will be a lot easier. So basically, that's kind of the direct end of it. Is like we will have more machines, more software, better stuff, so that won't stop. The two biggest thing is really we need to kind of push hard. As we're still a pretty small group, especially in the wood world, but we need to sit together and kind of push for that and come up with solutions for the industry and not solutions for individual companies. And the other thing is the whole education. It's nice to see with OSU now, and that we've done stuff at UBC, but it's those schools they are embracing that. It sounds like OSU is going to get some equipment like CNC machines. At UBC they already have a Handegger, and so it's nice that those schools are trying to offer that, and hopefully they will use it a lot and make that equipment available for their students. So yeah, that's pretty much it in terms of kind of a quick overview. I don't know if maybe we'll have a quick. How much time do we have? Are we done?
A few minutes for questions.
Yeah. So like I said, this is kind of my Australia presentation. That's part of it, but the other part is like we are local here, and we have those machines. If anybody ever wants to come, stop by and have a look, like we're always trying to have open doors, and it really is different when you see it in person. And if you're ever involved in a project, if anything, steel cutting or whatever, I would really encourage you to go to those fabricators and kind of ask the right questions and really check it out. It's suddenly when you see it, everything just like you kind of look at it at a different angle. And I see that it's like the people that we work with that either work with technology like that before, or they came down and tried to learn it. The whole project is so much easier then, and so that's really helpful. Yeah, any questions in terms of, also in regards to, you saw Albina and you saw those machines before, so if you have any specific questions about that, I spent quite a bit of time with Albina, so I think I do remember all the details. So if you have a more detailed question about the frame or the CLT or any of that, I'd be happy to answer that.